So I thought we'd talk again about this bad boy right here. Hopefully you're going to focus. There you go. Relying on autofocus today, so hopefully it won't be too bad. Anyway, this is the Waveshare 1.54 inch LCD, I was going to say then. What I mean is e-paper display. I've covered this before just as a little review, but I've programmed it up now programmed my Wemos, so ESP8266. Got like a little cable there, I need to get rid of that. Programmed it up with what is a, are you going to focus? Oh, well, I'll just move it down. What is a sort of social media counter. And this is, when was that updated? God, is that today? Yeah, 8:22 this morning. So we can plug it in again. Where's the, oh, have I even got a cable? It should be powered on and about to update. It goes through a little loop first. Is it powered on? There we go. So I've programmed in a little image, it says checking the interwebs, something I drew myself and converted. We'll cover that in a minute. And then it updates the social media counter. Again, I'm not really going to cover how to do the social media side of this, just more about writing to the display and also what connections are needed in order to drive it. Using something like an ESP8266. In fact, we'll go with exactly that because I think that's the kind of board people are going to be using, specifically these Wemos ones. Now, some pins get mapped differently with different boards, but we'll cover what it is on the Wemos board, and then from there you can sort of adjust it to your own boards. I've also printed something, so you'll see down here, I've got this weirdly awful 3D printed horn. That's what I'm going to call it. You'll also notice my blue painter's tape. I just let it get wrecked, and then I sort of move my print around on the bed until this is until it's all wrecked, and then I replace it. But it's pretty hardy stuff. So I made a few little test prints. So this was my first one, and I realized I had to like cut bits out of here. If I come up a little bit, you'll be able to see that better. Focus. Are you going to focus? There we go, that's focused. So I had to cut a section out with a pair of pliers. Bit annoying. And we've got a sort of a split here. I don't know if that's actually going to happen with this new one, we'll see. So this one actually prints with that face down. And, yikes. So you'll see, in order to save print time, I cut this model down so it's not the same size. This actually, it took ages to print, like 4 hours or something like that. My printer is slow, almost time for a new one. I've also created a fascia for it, and because that's going to be incredibly difficult to get off, I've got two bottom sections to use. This one printed pretty badly, so I'm not quite sure which one I'm going to use. It's probably actually going to be the one that printed badly. And the idea is that, let's unplug this now. It doesn't need to be powered up all the time. It updates every 30 minutes at the moment, I think, or 20 minutes possibly. So this, oh no, it's the wrong way around. So you drop it through, and then if we line this up with that, then it sort of fits on top and screws through the screw holes. So they almost line up. They don't quite. I think I've mentioned before, I'm no 3D designer. I'm also not an expert at 3D printing. I just enjoy doing it. And it's a great tool to have. So anyway, we're going to be going over the coding for this. I'll talk about the code, actually how to do this, but I'm not going to give you all the code for it, just because it's not a standard library for Arduino. You have to have your own server in order to achieve stuff on the Twitter API, because it uses this OAuth thing, and I don't think there's a library for that yet. There might be, I might be wrong, so someone out there might know some. You can use the YouTube API library to get the YouTube stat if you want to, but I know a lot of you don't do YouTube and aren't interested. I don't really care about this, but it's nice to have a little display that changes. This would be ideal as a clock, but you would have it update, say, every minute. You wouldn't have it update every second, because the display takes a little while to update. As you saw, we'll go into how quickly you can make it update and see if we can improve that with just some text. And I'll also talk about how to create images on here. I'm going to be using Photoshop because that's what I generally use, but you can use other bits of software as well. So let's see if it fits inside this thing. So that came off relatively easily. And we've got, come on, are you going to focus? There you go. So we've got the section here. It looks like it's probably going to split again, honestly. It looks like it's barely holding together there. I've got some screws here somewhere in my pocket. And do I have a screwdriver? Probably not. Yeah, it turns out I do have a screwdriver. So let's try throwing this in here just so that we can see it standing up. So the idea was that you'd have this sitting on a desk like that, and there'd be a battery in here sort of weighing it down. And then, so to your perspective, it would be pointing out at you. So a vertical display. Or horizontal, I don't know which it would be. There's plenty of cable here, unfortunately, probably a bit too much. So does this fit? Do they line up? That is, let's zoom in a little bit, shall we? Do they line up? Do they heck? Oh, almost. So those two bottom ones line up and, oh, that's close enough, right? Yeah, I'm happy enough with that. Let's put some screws in and then we'll see how far off it is. I mean, the plastic's going to give a little bit, hopefully. Oh, there we go. We just about made it. If I just get, oh, crumbs. If I just get two in, I think I'll be relatively happy. It doesn't need to take a lot of strain or anything. It just needs to hold in place. So let's just get two of these in and then we'll put the front on so that you can see. I can hear plastic cracking, so I know it's not perfect. Let's come out a little bit, shall we? There we go, that's better. Now the front is just another bit of plastic that fits over the top, wrong way around, David, that fits over the top and pretty much hides the rest of all of that display. I'll make these files available for you to mess around with. Again, remember, I am not a 3D designer. These things do not fit perfectly. Oh my God, focus. Focus. They don't fit perfectly, as you can see here. There's sort of a, yeah, it's just a bit crap, but you know, I've tried my best, and if my best isn't good enough, which it isn't, then, you know, 3D printing can go to hell. Anyway, now before we get started doing the programming bit, I thought I'd get this bit out of the way first because it's going to be important before you start doing it. So let's figure out where these lines go, and you can see here we've got busy, reset, DC, CS, CLK, DIN, ground, and 3.3 volts. So we've got busy, reset, we've got DC, CS, clock, data in, ground, and 3.3 volts. Now these ones are easy. You know where that's going. That one's going to ground. This one's going to whatever your 3.3 volt source is, which can be slightly higher. There's some tolerance here, so I wouldn't worry about giving it 4 volts. That's fine. Now your data in is the blue wire, and that is going to pin D7 on the Wemos. So let's bring that over, D7. Now they have their different pin mappings for the GPIO on the ESP8266, but on a Wemos it's D7. You can look up what those pin mappings are. Next up we have our clock signal, and that's going to D5. Now some of these can be changed in code, and we'll look at where that is, but for now this is what I'm using. The next one we've got is the CS pin, and that is on D8. I'm running out of space here. We're just gonna have to, you're gonna have to put up with the fact that it's a bit higgledy-piggledy there. And then next we've got DC, which is on D3. And we have reset and busy, and reset is on D4 and busy is on D2. Those ones are definitely user controllable. So D2. Okay, so that is essentially the connections I've got here. I do have a wire going from D0 to reset on here, and that's for my my deep sleep timer. So when that timer runs out, the watchdog wakes up the controller by resetting it. So that's what we've got going on. Let's go into the programming side. Right, so we've moved upstairs because my laptop battery ran out and I lost everything I just recorded, so you'll see the time is significantly different. However, we'll carry on regardless. We've got this on the bench and I've got the code up on the screen. This is the test example for the GX-EPD SPI test example. Now, that's what I've used here to create this sub counter. I've modified it pretty heavily, but this is essentially the same code. So if you go into this example, it asks you to select the display class that you use. Now, I think on this example, this one is usually uncommented, but you're going to want to comment that out and bring in this one, and that's the display class for the 1.54 inch display. That means it sets the size of the display and how you communicate with it, as well as the color space that's used. Now, I can upload this straight to the board and it will work. So it says here, if defined ESP8266, and down here you'll see it says D3 and D4. Those are my connections that I've got for the SPI, so it's the CS, the DC and the reset. And then if we look a bit further down, we've got our IO class, and the IO class is D4 for the reset. Again, that's specified here. And our busy pin, which is D2, and they match ours. So the default is fine. And hopefully I should just be able to upload this and you'll see what the default example looks like. So it is uploading at the moment, and there we go. So it's going to shoot across here and you'll see it update on the display. You'll also see how quickly it can update. So this isn't using any of the same kind of delays that I'm using. So this is essentially the speed you can do a full screen update. Now it does, in between these, it does flash the display white and black, and that's because it's doing a full refresh. The library does support partial refresh. I don't know what that is. That's just weird. But I'm not using it. So this one's just going through some text and images that are stored in this example and in the library. And you can see there's little icons there, and then we get to text. So let's jump to my example. It's not really an example. I'm not going to give you the code for this. I'm just going to show you how it works. So I've essentially got exactly the same example set up in a very similar way. However, I've got some extra code in here. So you'll notice we've got something that says YouTube, Twitter, interwebs. Now interwebs, if I upload this to my board, interwebs is the image you see when it first loads up. I've changed the code slightly in here in mine to, you can see it's interrupted as it was updating the display, so it's not completely done it. That's interesting. So mine will show an image on here. There you go, checking the interwebs. Not for very long. I've changed the delay so it's a bit quicker, and this will now refresh every minute. But this is the image data. It's in an array, and I will show you how to make these. But first off, let's scroll really quickly down to the bottom so you don't see any passwords and stuff. Because this is running from my web server, the PHP for this. You can use libraries like the YouTube API and the Twitter API libraries that are available for the Arduino, but I'm not using them because I'm more comfortable doing it myself. But there are lots out there that you can use. So my function, after it pulls in all of the data in a very horrible way, we've got show interwebs, delay 500, it's 500 milliseconds, and then show subs. And I was sending it to sleep, but for this example, I'm going to take that out. Now, show subs, all you do is you're essentially using the Adafruit graphics library. And if anyone's used that before, I've used it on LCDs before, and it's really, really easy. You essentially have your X and Y as a pixel grid, and that's how you can set the cursor and draw bitmaps in specific locations. The GX-EPD library piggybacks onto those methods. The set color feature here uses a specific color for this display, and they have different colors on here. You'd think it would just be a hexadecimal white and black, but it's not. It's a different instruction for this kind of display. You can use the fonts available from the Adafruit graphics library. For example, this 9-point font is used here in the word YouTube, which we can just change if we want to say what's up, and we can well, it should probably have an apostrophe in there, shouldn't it, and maybe a question mark. So let's add that in and we'll upload that. So we can just quickly edit stuff in here, and it's all relatively simple. So you've got print line to a display, that can just be text, or it can be a variable. So down here I've got print line subs count, and that's a variable printing to the display, just a number. So you'll see that that has changed to what's up now. So simple to change this stuff. Again, writing bitmaps to display. You might be used to doing that with LCD displays before. We've got the YouTube bitmap just next to what's up. It is 5 pixels from the left of the screen and 0 pixels from the top. We can change that. So let's throw in 100 and 100, which should put it somewhere near the word Twitter, and we'll upload that now. So super simple to alter what's on the display. And because this is just in a function, then we can call that function whenever we like. We can add a variable into the function up here if we want, and have that variable print out on the screen. Now, these are brilliant displays because they don't use a lot of power. You'll see that YouTube has jumped down somewhere near Twitter now. So yeah, it's super simple to mess around with. But I thought it might be nice if we figure out how to create an image to display on our e-paper display. So what we're going to do is we're going to pull up an image off the internet, and we're going to try and convert it into something we can display on the screen. So in order to do this, you're going to need a couple of things. You're going to need something like the GIMP image manipulation software. I'm going to use Photoshop because that's just what I have available. But GIMP is free if you want to use it, but you're also going to need to use image to LCD. Now this is from Good Display. They're the people that made this display, and it's free to download and install, and it's really, really useful, and we'll get onto that in a second. But for now, we're going to need an image. So let's look for an alien. I'm just going to load up Photoshop, and let's pick an image of an alien. Now, because this is a black and white display, there's very little ability to create any kind of grayscale image. We're going to choose something that's pretty high contrast. This seems to be quite high contrast, so let's click View Image. I'm going to copy that image. Now it is massive. It's a lot larger than our 200 by 200 display. So let's bring Photoshop into frame, and we'll do File, New. It's going to bring something in from the clipboard. That's okay. We're going to just choose that and paste our image in. Now, because this is a PNG, it has a transparent background, but it's turned that into a black background because I just dragged it in. So let's change that to white, and then we're going to posterize this image. So what Posterize does is it reduces the number of colors in the image. So I can just take it right down. So Posterize to 2 levels for the colors. And then we can pretty much just leave it like that. And then we're going to put it into a new image. So if we go to File, New, then I want a 200, that's 200 by 200 pixel image. And we're going to turn it into a bitmap, a 1-bit bitmap. So just click Create on there, and that's it, we've done it. So now I want to resize this image before I send it in there. So image size, now its long edge is the height. So I want to make sure that height fits in with my display, and its width is going to be 140, and that's okay. So I'm going to click OK. Made it really tiny, so let's zoom in, and you can see now that it's got lots of individual pixels. We've still got some blue in here, but that's not a problem. So I'm going to select everything and copy it. Then we're going over to this image here, and we're going to paste it in, and it's going to take out that blue. It's going to resample it into the palette that that's available, which is 1 bit. So that's on or off, isn't it? So that's black or white. So that's what we've got here. And it's turned that blue into a sort of shaded area, which is fine. I think that looks really cool, so I'm happy with it. Now I'm going to need to save that image as a BMP, and then we're going to open it up in Image to LCD. So we'll just load up Image to LCD, then click Open, and there's our image amongst loads of others I've been messing around with. So just click Open, and it loads up inside. I can't really make this much bigger, unfortunately, but loads up in here, and this is where we get our preview of what we're going to get out. Now most of the standard options here are fine. Your max width should be 200, but we're going to reverse the color and we're going to mirror it left and right. That's because when it writes this image to the display, the black is going to become white and the white is going to become black, and it's going to reverse that image. So we just click save. I've already done this, so I'm going to call it alien 2 so that we're saving a different file. And then it opens up our array. These are the values that we're going to need to plug into our sketch. So let's copy all of that. Copy all of that. And let's load up our example. So I'm going to scoot up to the top. And let's overwrite the example we've got. So we've currently got an image in there that's popping up called interwebs. So let's call our current image interwebs 2. We'll paste in the new one, so we don't have to mess around with the code too much. And we'll call this one interwebs. Now if I scroll right down to the bottom, we'll make it show up for a bit longer, let's say 5 seconds, and then click upload. And it literally is that simple. So let's watch it fly onto the display, and then we should see 5 seconds of an alien face. Hopefully. I've also done my own face on here, so I'll show you that in a second. So there we go. That was pretty easy, wasn't it? And you'll see that it has mirrored that image. So if we bring up the display again, let's reset the controller just so we can get that same image back. So you'll see we converted with the black image there, and we actually got the reversed image with a white background. So it did work well. Let's change this to show face, and we'll get rid of show interwebs. Show face down here just shows David, which is another one of those images I've created at the top. So if I upload this back to the display, to the Wemos we've got there, and it's always the slow bit, isn't it? Still, it uploads very quickly. And then we'll get my face for a bit. So you can see you can get quite a lot of detail in these images, and it almost looks like it's a grayscale image, but it's not. It's just black and white, and it's just sort of dots all over the place, and it appears to be grayscale. So really sweet little displays. Okay, well I think that is about it. That's all I need to show you. So hopefully that's been informative, and I will finish this up. I'll pop the STL for this 3D thing. If someone wants to help me improve it, that would be amazing. But I think it does look quite nice with the thing on the top there, sort of hides most of the display. I mean, that would be sort of glued on. The screws that come with this thing sort of self-tap a bit, so they hold themselves in there pretty well. And once it's weighed down with a battery, it'd be great. Anyway, I will speak to you all soon. Hopefully you've enjoyed that.